Today, we're going to pull back the curtain on one of the most powerful and honestly fascinating parts of AI, reinforcement learning. It's all about how we teach machines to master incredibly complex tasks, not by handing them a rulebook, but by letting them learn from trial and error. Pretty much the same way we do.
So, how does this actually work? Let's start with a puzzle. Imagine you want an AI to get really good at a video game. But here's the twist. You can't tell it the rules. You can't explain what's a good move or a bad move. The only feedback it gets is its score. How does it possibly go from just mashing buttons at random to playing like a total pro? Well, that's the exact problem reinforcement learning was designed to solve.
So here's our game plan. We're going to start with the basics, learning through trial and error. Then we'll get into a really critical choice every learning system has to make. Should it explore or should it exploit? After that, we'll give our system a deep power-up and see how that completely changes the game. And finally, we'll look at how this tech is already making waves out in the real world.
All right, let's dive into the absolute heart of it all. Reinforcement learning is built on one of the most basic ways anything learns, just simple trial and error.
So, what are we really talking about here? In RL, you have an agent, that's our learner, and it's trying to make a series of decisions inside of an environment. You know, the best way to think about it is like teaching a dog a new trick. The dog is your agent, the living room is the environment, and that little treat you give it, that's the reward. You don't tell the dog exactly how to sit, right? It just tries a bunch of stuff, and when it gets it right, it gets a treat. Over time, it connects the action to the reward.
And this whole process just repeats in a constant loop. First, the agent looks around and observes its current state. Then, it takes an action. The environment reacts and gives it a reward. Could be positive, could be negative, could be zero. That action puts the agent in a new state, and the whole loop starts over. This happens thousands, sometimes millions of times, and with every single cycle, the agent gets just a little bit smarter.
Okay, but this learning process creates this constant, nagging problem, a dilemma that really shapes the agent's whole strategy.
At every single moment, our agent has to make a really tough call. Does it stick with a strategy it already knows works pretty well? Or does it try something totally new, something that might just lead to an even bigger payoff?
This is the famous explore-exploit dilemma. On one hand, the agent can exploit its existing knowledge. You know, if it knows a certain move gets a pretty good score, it can just do that over and over. It's the safe bet. On the other hand, it can explore. It can try a totally random, untested move. Now, this is risky. It could lead to a terrible score. But it's also the only way the agent can stumble upon a brilliant new strategy that could lead to the highest possible reward down the road. Finding that perfect balance is everything.
So for decades, reinforcement learning was powerful, but it was kind of stuck working on simpler problems. Then a massive breakthrough happened that let it tackle incredibly complex stuff, and it all came down to adding just one word: deep.
So what makes it deep? It's simple, really. We're talking about deep learning. We basically give our agent a deep neural network to act as its brain. And this is a total game changer, because instead of just understanding a simple board with a few pieces, it can now process the messy, complicated data of the real world, like all the thousands of pixels on a screen at once.
The impact of this was just huge. Suddenly, the agent didn't need a human to simplify the world for it. It could learn directly from raw images or sounds. This just blew the doors open, letting RL tackle problems that were completely impossible before, because the network can figure out what's important all by itself.
And this led to a massive aha moment for the entire field. When researchers at DeepMind built an agent that learned to play old Atari games just by watching the screen, it didn't just learn, it got so good that it achieved scores comparable to that of a professional video games tester. This was the proof. This wasn't just a theory anymore, it was an incredibly powerful tool that actually worked.
But look, this isn't just about getting high scores in old video games. The exact same ideas are now being used to optimize unbelievably complex systems in the real world, and the impact is massive.
When you think about it, the skills an agent needs to master a game, spotting patterns, thinking long-term, adapting on the fly, those are the exact same skills needed to solve some of the toughest business and engineering problems out there.
So where is this stuff showing up? Well, it's being used to train robots for tricky manufacturing jobs. It's optimizing routes for services like Lyft and Uber. It's actually controlling the cooling systems in Google's data centers, saving tons of energy. It helps recommend what you listen to next on Spotify. And yeah, it's even being used to build automated financial trading systems and manage our 5G networks.
To really see this in action, let's zoom in on that last one. Let's look at an agent that taught itself how to trade in the wild, volatile world of cryptocurrency. So researchers built this agent. They trained it on old price data, and then they set it loose on 66 days of market data it had never, ever seen before. With an initial investment of $10,000, the agent managed to generate a profit of $4,850.
Okay, so how in the world did it do that? Let's break this down. The graph on the left, that's the market price. See those little dots? The green dots are when the agent decided to buy, and the red dots are when it sold. Now look at the graph on the right. That shows the agent's account balance. You can see how the agent's decisions on the left directly created that steady upward trend on the right. It figured out a profitable trading strategy from scratch.
So what's the big takeaway from all this? It's that reinforcement learning is at its absolute best in situations that are complex, always changing, and just drowning in data. It's an expert at finding these incredible long-term strategies that a human might never even think of. It's not just about making the best move right now, it's about making the move that leads to the best possible outcome way down the line. And that brings us to the most fascinating question of all. If this technology can find strategies that are beyond human intuition in games and financial markets, what happens when we point it at our other big challenges? Imagine an agent discovering new scientific materials, or optimizing the entire global supply chain, or managing a city's power grid. The potential is just beginning to open up. So what problems do you think it'll solve next?